Okay, today we're in section 7.1, relations and functions. Essentially, relations and functions actually have quite a bit in common. There's one key difference, one major difference between the two of them, and it's my goal by the time we get to the end of the lesson that you understand the difference between the two, okay? It all starts with terms and definitions, okay? Whether it's a relation or a function, they are both expressed or shown using ordered pairs or mapping diagrams. So that's what we're going to see a lot of today. I gave you three examples, or three, I don't want to say examples, but three, you could call them tester ordered pairs that we're going to kind of show you what's an input, what's an output. So just go ahead and write those down for now. And then two main definitions that you need to know. A relation pairs inputs with outputs. It's literally, if I said make up 5 ordered pairs and write them on your paper, you just wrote a relation, okay? So a relation really is just a set of ordered pairs together, okay? In order for it to be a set, it needs to be 2 or more, okay? A function, now every set of ordered pairs is a relation, but it does not mean that it's a function. A function pairs each input with exactly one output. We're going to explore that more later in the lesson. I think like example 2 and 3, even example 4. Okay, so we'll look more specifically about what's a function and how to tell if it is or not. Okay, so just for now, just go ahead and get these written down. We'll look at a couple more things and then we'll move on. See 3 ordered pairs here, and within the ordered pairs 0, 1, which one is my x value? 0, 1. 0. My x value comes first and my y value comes second. So that's just, kind of like a review type of question. It's been a while since we looked at an ordered pair. With 0, 1, 0 is my x value and 1 is my y value. Well, the difference here is I don't see x and y with an input and an output. So what you need to understand is that my input values are always my x value in the ordered pair. Input is x, so what do you think output's going to be? Y. Okay, output is going to be y. So when you're looking at an ordered pair, 0 is your input and 1 is your output. So in the second ordered pair, which value is your output? 2. And which value is your input? 1. And on your third ordered pair, which value is your input? 2. And which value is your output? All right, so we're just training ourselves to recognize what's an input, what's an output. Input is my x, output is my y. All right, and that's really important when we're trying to transfer data or transfer information. We have to understand which one's x and which one's y. Okay? Any questions so far? Inputs, outputs, relation function, we're not quite there yet, but we need to see some examples to really understand those. All right, so let's go to example 1. In example 1, we have mapping diagrams, okay? And a mapping diagram is basically 2 sets of information, your input and your output. So you got your input and your output. And these arrows between the two of them are actually very important because the arrow shows you which input value is matched with which output value. Without the arrow, you have no idea how they match up. No clue. All right? It could be any one of the values. So the arrow makes all the difference. It's always going to be in your book on a quiz or a test. The arrows will be there on a mapping diagram. So all you have to do is match them up in an ordered pair. The first ordered pair. For the input value of 1, what output value or y value is it matched up with? 3. Okay? So the arrow tells me which output value 1 is matched up with. All right, it's not always going to be that straightforward. We'll see how it kind of jumbles up a little bit on some of these. But for this one, it's pretty straightforward. What about 2? Where does 2 match up? 2, 6. So 2 is my input, or my x value, and 6 is my output, or my y value. All right. What about the third one, Lily? It's going to be my third ordered pair from that mapping diagram. 3, 9. And Sherelle, what's going to be my fourth one? 4, 12. Okay? I'm simply writing the ordered pairs that match up with the mapping diagram. Okay? Now I'm going to answer a question. Is there a relationship between my input and my output values? For example, as my input values increase, are my output values increasing by a consistent value? Yes. Sometimes it's random, and the answer is no, but sometimes there is a pattern. What you think, Maya? Okay, it goes higher by how many?
3.
Well, the input. The input increases by 1, the output increases by 3. And that's just what you're going to say. As the input increases by 1, the output increases by 3. All right, and it has to be the same every time. So if there is no pattern, then you just say none. Okay, so good job. Nailed it right on the head on that one. All right, so let's go ahead and write down our second mapping diagram. All right, remember this entire thing is the mapping diagram, the input and the output together. We're going to notice some differences on this mapping diagram. Obviously, you know, it's pretty obvious, so we can state the obvious, you know, what we see that's different. Go ahead and write down your input and your output values. If you think you can, go ahead and start writing down your ordered pairs. Okay, some of you might be able to go ahead and go to that step, and we'll talk about it. It's really important when we're pulling the ordered pairs out that we cover all of them. Okay, so for the first one, my input of 0, what is the matching output? 0. Okay, so just 0, 0. For my second one, 2, what is my output? 1. And what is it? Those are 2 separate ordered pairs. I can't just write 2 y values in the same ordered pair, okay? So because the input 2 has 2 outputs, I need to list them separately, okay? What about my next ordered pair? What's it going to be? 4, -3, okay? And that's just 1, so that's fine. All right, so we see that my input values are increasing by 2. I go from 0 to 2 to 4. And 0, 0 is my first one. Obviously, to get from 0 to 0, you have to add 0, right? 2 to 1, am I following the same pattern? 2 to -2, am I adding 0? No. Okay, so there is no relationship. There is no pattern here. I just say none. All right, so sometimes there is a relationship and sometimes there's not. But it has to be the same operation to each input and output value. All right, and that pretty much covers example 1. So we're just learning how to read the mapping diagram and pull out the ordered pairs. We go with that? You guys understand? All right, so now in example 2, I'm looking at these mapping diagrams and now I'm asking myself, is it a relation or a function? And guys, just try to understand this. Every set of ordered pairs, as long as it's multiple, which it is here, it's always going to be a relation. A relation is just a set of ordered pairs. So obviously these are relations, but are they functions? Okay, there's one rule and one rule only. Go back to the beginning of your notes. The beginning of your notes. Let's see, Sarah, can you read me the definition of the function? What is a function?
Each input with exactly 1 output.
Okay, pairs each input with exactly 1 output. That's the important part, okay? That's the part that I'm looking at. So you don't need to write the ordered pairs, okay? Go ahead and write down the mapping diagram, but you don't need to list the ordered pairs. Just write down the first mapping diagram here. Your input and your output, draw your arrows, And then we're going to answer that question. Is it a function? Okay. So my rule is each input has to have one output. Okay. So -9, what's the output? 0. -2, what's the output? 5. 5, what's the output? 10. And for 12, the output is 10. So here's the catch. Okay. Two different inputs can have the same output. Actually, all of the inputs could have the same output and it still be a function. All right, so even though 5 and 12 share the same output of 10, it is a function. I say yes because, and the why part of it is very important. If you understand the why, you're going to get these right all day, every day. Okay, it doesn't matter what ordered pairs I give you. Each input, and you can abbreviate because each input has one output. Okay? You say, well, they had the same output. That's okay. If they have the same output, two different inputs have the same output, it still falls under each input had one output. All right? Don't overthink that, okay? So I'm kind of guilty of that, overthinking. Anybody else kind of like that too? I start overanalyzing something and then it becomes confusing to me. But really, when we just think about it very simply, each input has to have one output, and that happens here, so it is a function. All right, let's look at our second mapping diagram now. Input and output. Go ahead and write them down, draw your arrows, finish filling it in, and we'll go from there. Now we're just going to answer the question, is it a function? Okay. Okay, so I hear a lot of no's. All right, let's kind of just go down the list. -2, what's my output? 4. -1, what's my output? 3. 0, what's my output? 5 and 6. So let's stop there and talk about why this now makes it not a function. All right, let's say I had an equation. All right, and it was, I don't know, well, actually, let's just back up to basic numbers. 2 plus 3, all right, is most basic form. What's 2 plus 3? 5. Can it be any other number? No. So if these are input values that I'm actually plugging in for x in an equation, there's only going to be one answer. 2 plus 3 is 5. It can never be any other number. So the fact that you plug in a 0, hypothetically, into an equation and you get 2 answers, that's never going to happen. Okay, so that's why in reverse, one input cannot have 2 outputs. When you plug in a 0, you're going to get an answer. It's not like, well, I feel like it's going to be a 6 today or a 10. No, 2 plus 3 is 5. Okay, it's no other number. Does that make sense? Okay, so I know that's kind of a separate analogy, but hopefully that helps you understand why one input cannot have 2 outputs. All right, so I say no. My answer is no, it is not a function. But I have to say why, okay? Because 0 has outputs of 5 and 6. So I'm stating the why, all right? This is not a guess. I'm not saying, oh, flip a coin and it's yes or no. I understand why it's not a function. 0 has outputs of 5 and 6. Now I'm calling out which one of those inputs actually makes it not a function. Now, what if you had more than one input that has 2 outputs? You only have to list one of them, okay? So if all of those inputs had multiple outputs, you only need to give me one example as to why, okay? You can give me more if you want to just go the extra mile. All right, any questions on what makes it a function? Anything? Okay, so example 3. Has anybody ever ridden a subway train? New York City, Chicago, Boston, anywhere else? Yeah? Where was it? New York? Mexico, they got subways there? Okay. All right, Trey? New York. Okay, very good. Anybody else? Okay, so I actually went to New York City for the first time last year and rode the subways. It was really an interesting experience. If you ever go to New York City, definitely ride the subways. It's cool. It definitely gives you the whole, whatever, experience of New York City. All right, so that's kind of what this example is talking about here. All right, I do have a small typo that I keep forgetting to correct. That should say one way. All right, so the mapping diagram, which you do need to draw. You don't have to write out all the sentences in the scenario that I'm giving you, but I need you to write this mapping diagram on your notes. Okay, it shows the prices of one-way subway tickets to different zones of a city. And it kind of makes sense, right? The longer you ride the subway, the more money you're going to pay. The more zones you pass through, the more money you're going to pay. We'll talk more about that in a minute. All right, so we have the mapping diagram, and now we're going to answer these questions. These questions are basically the same questions that we answered in examples 1 and 2, except now it's just, this is a real life example. This is something that we could experience, that we could actually do. All right, so hopefully that helps you make that connection. So is the price of a subway ticket, that would be my output, a function of the zone number? That kind of seems like a weird question, but something should kind of set off a flag with me. Function. What makes a relation a function? Each input has one output. Okay, so I look at my input values and my output values. Does it match that criteria? Yes, it does. So I say yes. Because, but now here's the catch for example 3. You have to call the categories what they are. The input values stand for the zones. Each zone has one price. You see how I did that? I didn't say each input has one output. I called the categories what they were. Each zone number has a price from the starting point. However many zones you're passing through has a dollar amount. That wouldn't be fair, would it? If, let's say, someone gets on and they say, oh, you're going through 2 zones today, that'll be $5. And then the next person comes through, oh, you're going through 2 zones today, that'll be $2. Well, why does he pay $3 less than I did? No, I mean, that doesn't make sense. So everybody pays the same amount, right? It's all equal. All right, so that's kind of another reason behind why, you know, the diagram's set up the way that it is. All right, so yes, it's a function. All right, number 2. What is the relationship between the price and the zone number? What is the relationship between the price and the zone number? So just to get on the train, how much do you pay? $2. Okay, so before you even go anywhere, just to get on the train, you pay $2. And then what do you notice?
Whichever zone you're going, it increases by $1.
Okay, but do you see what she did there? She called the categories what they were. She didn't say each time the X goes up by one value or 50, okay, we're calling it the category. So in example 1, when we described the relationship, there was no label. So we would say X and Y, or input and output. But here, to describe the relationship, we would say for each additional zone, the price goes up $1.50. All right. And I can actually use this information. Let's say I want to take my kids to the zoo. And I know I need to use the subway. And I know I'm going to pass through 5 zones to get there. If I know this information, even though 5 zones is not on the mapping diagram, I can use this information to figure out how much money I need. Go ahead and write that down if you think you know the answer. Ethan, what do you think? Yes, you are correct. Because I'm going through 2 more zones at $1.50, that means 3 more dollars. So $6.50 plus 3 is $9.50. Or you could just take it a step at a time. 4 zones is how much money? At $1.50 to $6.50. 4 zones is $8, and then 5 zones would be the $9.50. Okay, so we're making an application there. We understand the pattern, so we can apply it to a value that maybe isn't listed. All right, one more example and we're done. You do not have to draw the graph. You don't have to draw the graph. All we're going to do here is we're going to make an input-output table, a mapping diagram, from the ordered pairs, and we're going to match them up to determine if it's a function. All right, remember, we only have one rule to say whether or not it's a function. All right, so here we go. All right, you do not have to draw the graph, but you do need to draw the mapping diagram. Input and output. Okay, so we have input X values, and your output is your Y values. Okay, and let's go over here to our first point on the graph. All right, we always read these left to right, so let's look at the first point. What is the input value or the X value for that point on the graph? And maybe that's kind of hard to see. Let me see if I can. This point right here. Can you see that a little bit better?
-6.
I know it's kind of hard to read. What is the input value, which would be the X value for that point? -6. So that's what I'm going to write on my chart. Okay, is -6. Let me change that. Okay, and my output value for that point would be what? What's my Y value? 1. Okay, so now let's go left to right. Let's keep following the points. What's my next input value? -4. What's the output? 1. So since it's 1, I don't have to write it again because 1 is already there. What's my next input? -2, then 0, then 2. And what do they all have in common?
They all have the same output.
They all have the same output. But remember, on a mapping diagram, I draw the arrows to show that they all match up with an output of 1. So my arrows kind of start looking like a big blob, but that's okay. All right, so does it match the criteria? Does each input have one output?
Yes.
Yes, it does. It's all the same output, but that's okay. All right, it is a function. But to answer the question, I need to say my answer to this question is yes, each input has one output. But my proof is in the mapping diagram. All right, because anybody can learn, well, that's my same reason every time. So if I say yes, that's what I say. Well, how do I know that you weren't guessing? It's this, it's your mapping diagram, okay? So without that, you're not gonna get credit. Or you have to show the mapping diagram. All right, so let's do a mapping diagram now for the second one and we'll be done. All right, so we've got an input, we got an output, input and output values. Input is X or Y. And output is Y. See, you learned something today. All right, very good. Okay, so go through these 4 points right here on the graph. And what is the X value for the point, and what's the Y value? And let's go ahead and list them. Does anybody think they know the input output for the first point? First point, Eric?
-4, 4.
Yes, so I'm going to go -4 and 4. And draw my arrow, showing that those two values match up. All right, go ahead and do the next 3. Okay, what's my second one? Logan, what's going to be my second pair? Okay, it's going to be -2, 2, going up 2. I know it's kind of maybe blends in with that line. So -2 up 2. What's my third one, Sarah? 0, 0. And what's my last one, Anthony? What's going to be my last one? 2, -2. Okay, and make sure you draw your arrows. Okay, so question of the day, is it a function? Yes, it is. Each input has one output. It's a function. All right, if you understand that, that's everything you need to know for 7.1.